Hello, I'm really excited to give my presentation. This presentation is really going to be a collaboration project. I'm excited to show you a lot of the tools that I use on a daily basis related to AI. I want to show my intentional collaboration of how I use AI to put together a presentation that showcases what AI is, because there is such a complexity about these models, and so many times people think of them truly as a black box. So I am going to use my knowledge and my training collaborating with all of the different AI tools that I love to use so much, and I'm going to explain AI using an analogy of a university model. And at the end of the presentation, stay tuned, because I'm going to show you the behind the scenes of what are the AI tools I used and how I used them to put this presentation together.
Today, we're tackling a problem that I think everyone has felt recently. You're reading an article about the latest tech breakthrough, or maybe you're sitting in a meeting listening to a consultant, and suddenly you just hit a wall of jargon.
Yeah, the buzzwords.
Right. Parameters,
Yeah.
tokens, deep learning. It's actually just math and logic.
And honestly, I think for most people, even the really smart people tuning in today, it still feels a little bit like magic.
Completely. It feels like the conversation shifts from technology to like magic spells. And that barrier keeps a lot of really smart people from actually understanding how these tools work.
They just use them and hope for the best.
We're working from a really unique set of research notes and a presentation created by Tricia.
And Tricia did something truly fascinating here. Instead of just writing a definition guide or a dense textbook summary, she actually sat down and brainstormed with an AI, with ChatGPT itself. She used it to create a metaphor that explains the AI itself. Together, they came up with what she calls the university analogy.
It's a brilliant framework, honestly. The whole idea is that if you stop looking at large language models or LLMs as this black box or robot brain,
And start viewing them as a student moving through the higher education system.
yes, the technical details actually start to make perfect sense. We're going to walk through Tricia's analogy to explain how these models are trained, how they differ, and why they give the answers they do. Wait, let's start at the beginning then. Orientation day. In the technical world, I think this is called foundational training or pre-training, right?
Yeah, exactly. But in Tricia's analogy, this is phase one.
So think of a massive foundational model, like the base version of GPT-4 or Claude, as an undergrad student walking into a massive university.
Okay.
When they first arrive, they aren't majoring in anything. They are just taking general education requirements, but on a scale that is honestly hard for us to even comprehend.
Well, we always hear about these models being trained on the whole internet. Is that literally what's happening? Is the student just sitting in the massive library reading every single book ever written?
Essentially, yes. The source notes mention that GPT-3, for instance, was trained on approximately 499 billion tokens.
It's massive.
But let's pause there for a second. What exactly is a token in this context? Because I think you hear that and you just think like an arcade coin.
Yeah, that's a really key definition.
Yeah.
In the AI world, a token isn't always a full word. It's more like a chunk of text.
Okay.
So it might be a whole word like apple, or it might just be part of a word like the ing at the end of a verb, or a prefix like pre. So 499 billion tokens roughly translates to hundreds of billions of words. It's like sending this freshman to the library and telling them, hey, read every book, every website, every Reddit thread, and every coding manual you can find. The model is becoming a generalist. It's learning the structure of language itself.
It's learning context, basically.
Exactly.
Right.
It's not just memorizing isolated facts. It's building a huge statistical map of how human concepts relate to one another.
The model isn't reading sentences the way you or I do.
What is it doing then?
Analyzing statistical relationships between these tokens, it's predicting the next word in a sequence.
Interesting.
If the student reads enough medical textbooks, they learn that symptoms usually follow a diagnosis. They learn the structure of logic itself just by observing the mathematical patterns of human language.
It learns the patterns of the world by looking at all this text.
But not all universities are the same. And this is where Tricia makes a distinction that I think is really valuable for businesses, or really anyone trying to figure out which tool they should actually use.
Public versus private, right?
Yeah, she separates public universities from private universities. Walk us through that.
This is basically the difference between using a tool like ChatGPT versus a custom corporate AI model. Tricia likens models like Claude or Gemini or ChatGPT to massive state universities, public ones. They serve everyone. They're funded essentially by the public internet. They have these broad general purpose curriculums. They know a little bit about everything from Shakespeare to Python code.
versus the private university model.
Exactly. Think of a private model as a specialized, closed campus institute.
Like a private college or a specific seminar.
Yeah, so a pharmaceutical company, for example, might build a model trained only on their proprietary chemical research.
Oh, okay.
That student isn't reading Reddit, it isn't reading X or Twitter, it's reading highly confidential clinical trial data and internal reports. So it's a smaller, cleaner, and much more focused curriculum that isn't shared with the general public. And that dictates how you should use them, which we'll definitely get to later when we talk about the privacy warnings. But first, we have to understand how the student actually learns.
Right, because reading 500 billion words is completely useless if you don't retain anything or understand how concepts link together.
Right, which brings us to phase 2 of Tricia's analogy, campus life.
And in the tech world, this is the neural network, right?
Exactly. The neural network is the architecture of the brain. Tricia points out that learning isn't just memorizing facts in total isolation.
Right, you learn by making connections.
Yes. You go to a history class, and then maybe a math class, and then you talk to a friend in the dorms who is a philosophy major.
And those interactions change how you process the information. Like you start seeing how history influences math or how philosophy changes your view on law.
This is where the concept of the neural network comes in.
If you ask a computer scientist what a neural network is, they will start drawing circles and lines on a whiteboard. But in our university analogy, the neural network isn't a brain structure. It's the campus culture.
The things I learn in one area eliminate the things I learn in another.
Exactly. Knowledge connects. That is essentially what a neural network is doing. It's composed of layers, specifically hidden layers.
Hidden layers.
So the hidden layers are where the synthesis actually happens.
Right.
It's those late-night dorm room debates where concepts get mashed together to form new ideas.
That's the campus life aspect perfectly.
Right.
The output, the final paper or decision the AI gives you, isn't just an isolated fact retrieved from a hard drive.
Like a standard Google search.
Right, it's not a search engine. The answer reflects the entire history of its learning. That single input traveled through millions of these little interactions and connections to get to the answer.
But as it passes through, it gets transformed by the interactions between these layers.
Transformed how, though? Is it just getting passed along like a game of telephone?
No, it's way more sophisticated than that. It gets transformed through weights and biases. Those are the technical terms. A weight is how much influence one piece of information has on another. If I tell you the sky is green, but your brilliant geology professor who has a high weight in your mind says the sky is blue, you listen to the professor.
Because the connection is stronger.
Right. The model learns which inputs should carry more weight in the final decision.
So it assigns importance to certain connections over others based on its training.
Precisely. And bias. If the bias is set a certain way, the student won't pass the information along unless the signal is really strong. If the bias is different, they might just blurt out everything.
So as the data travels through these layers, it's being weighted, filtered, connected. It's active processing.
And the output, the answer the AI finally spits out to you, isn't just it reciting a fact it memorized from one book. It's the result of billions of weighted decisions happening in a fraction of a second. Okay, this actually helps explain something I've noticed, and I think a lot of our listeners have too. If I ask ChatGPT a question and then I ask, say, an open source model the exact same question, I get entirely different answers.
Yes, you will.
But even if they both went to undergrad and read the same parts of the internet, why are they answering differently?
Well, now we are entering the math department.
This is 3.
Phase 3 of Tricia's analogy. This is the technical side, but it totally explains why different models or students give different answers. It's why some feel super creative and others feel rigid.
And Tricia uses the concept of order of operations here, right?
Yeah, think back to basic algebra. Let's say you have the numbers 2, 3, and 4.
Okay.
If you add 2 and 3 first, which is 5, and then multiply by 4, you get 20.
Right.
But if you multiply 3 and 4 first, which is 12, then add 2, you get 14.
Oh, okay. So it's the exact same inputs, the same books in the library, but a different order of processing gives a completely different result.
Exactly. AI models have different equations inside them. Tricia compares it to different academic departments looking at the exact same text.
So the department's metaphor?
Right. Imagine you give a famous historical speech to the statistics department, the philosophy department, and the economics department. And they are all reading the exact same text. But their internal functions, their mathematical lenses, prioritize different things.
So models function similarly.
Some models are what we call deterministic. They are straightforward, logic-based models.
Like the math department.
Right. Others are probabilistic. They weigh chances. And some are generative, which means they're tuned to take risks and be creative.
Okay, so it's not that one is broken and the other is working. They just view the data through different mathematical lenses. You wouldn't ask the creative writing major to do your taxes.
Definitely not.
Right.
You need to pick the right department for the right task.
AI models are mathematical recipes. They use different equations and different architectures.
Can we get a little technical for a second? I want to know what these departments actually look like in the code. What are the options?
Sure. Let's look at two very different approaches to give you a sense of the range. First, you have something like decision trees or random forests. A decision tree is logic-based. It's a flow chart. Is the data X? If yes, go left. If no, go right. It cuts the data into smaller and smaller slices. It's very structured and very interpretable, very focused on rules and precedent.
Okay, so that's good for things where you need a definite black and white answer.
Then you have something like a variational autoencoder or a diffusion model. This is much more abstract. It deals with probability distributions.
Like the art department.
Or theoretical physics. It doesn't look for a yes or no rule. It looks at the vibe of the data, the statistical noise, and tries to reconstruct a pattern from it. Probabilistic, not deterministic. A model built on that math is going to approach a problem creatively. It's why image generators can create art that never existed. They aren't following a rule book. They are navigating a probability map.
I want to stick on that word deterministic. Sometimes this matters a lot.
A deterministic model implies that if I put in 2 plus 2, I always get 4. If I put in the same customer data, I always get the same risk score. But many modern AI models are stochastic.
Meaning there's an element of randomness built right in.
Exactly.
Which is great for writing a poem, but terrible for calculating my mortgage.
You have to pick the right department for the job. That leads us perfectly into the next phase, because at this point, our student has finished undergrad, they have a broad worldview, they've made campus connections.
But a liberal arts degree doesn't make you a surgeon.
No. For that, we have to move the timeline forward to phase 4, graduate school.
Or, as the tech world calls it, fine-tuning.
Fine-tuning. How does this work?
This is where you take that general model, the undergrad who knows a little bit about everything, you give it specialized training.
I see, you send them to grad school.
You don't build a massive new university from scratch just to train a lawyer. You take a smart graduate who already knows how to read and reason, and you send them to law school.
So, practically speaking, how do you do that with an AI?
You take a foundational model, like the undergrad version of Claude or GPT, and you feed it a very narrow, specialized diet of data. No more Reddit threads. You give it case law or medical journals or coding languages.
It narrows its focus to become an expert.
Right. It builds on top of its foundation rather than replacing it.
Okay, but how do we actually teach them during this phase? Because Tricia's notes mention there are a couple of different teaching styles, right?
Yeah, this brings us to phase 5. Supervised versus unsupervised learning.
Let's start with supervised learning. Tricia compares this to grading exams.
Yeah, this is the strict approach. We, the humans, already know the answer key. So we show the model a picture and say, this is a cat.
And if the model guesses dog?
We mark it wrong.
Yeah?
We correct it. We are supervising the output to teach it accuracy.
If you want accuracy and you have the data, you use supervised learning. So this is used for things like automation and prediction.
It's great for replicating known human knowledge. But unsupervised learning, that's where things get really exciting.
That's the pure research analogy, right?
Yes. Imagine sending that grad student into a library full of unorganized data and just saying, find the patterns. We don't give them labels. We don't give them an answer key.
Because we don't have the answer key ourselves.
Right. We just let the AI loose on massive data sets. And this is where the AI becomes a discovery partner. Because the AI can scan billions of tokens. It might notice a pattern that humans missed entirely. It might see that element A and element B appear together constantly across thousands of papers.
Right, because a human researcher might only specialize in element A and they never even read the papers on element B. And the model might come back and say, hey, I noticed that these thousands of images all share this specific geometric structure. It groups them. This is called clustering.
It finds relationships we haven't defined.
It finds relationships that humans might not have even noticed yet because the data set is just too big for our brains to hold. A human researcher looks for what they expect to find. An unsupervised model just looks for mathematical proximity. It might find a correlation between a specific gene sequence and a disease that no doctor had ever linked before simply because the pattern was buried in all the noise.
Exactly. So the AI finds the correlation, and then the human steps back in.
This is what they call human in the loop.
The AI finds a pattern, the humans form a hypothesis based on that, and then the humans feed that insight back into the model. It's a true collaboration.
It's not about replacing the human researcher. It's having the ultimate assistant who can read the entire library in a weekend.
Yes, exactly.
So let's talk about continuing education. Phase 6, we hear a lot about versions. GPT 3.5, then 4. In our university analogy, is this the student getting older or what?
Think of it as updating the curriculum. The university doesn't teach the exact same science today that it taught in 1950. Models are retrained with new data, the world changes, language changes. But it's also an update to the architecture itself. They refine those hidden layers to improve reasoning and improve safety.
Okay, so newer versions are basically safer and smarter graduates.
Usually, yes.
Now, before we wrap up, there is a huge privacy warning in Tricia's research that we have to talk about. It goes back to that public versus private distinction.
Oh, yes. Tricia calls it the public lecture hall problem.
Walk us through that, because I think people really trip up here.
When you use a public model, like regular free ChatGPT, it is like standing in a crowded public lecture hall and speaking to a microphone.
Everyone can hear you.
The data you put in might be kept. It might be used for future training.
So if I paste a confidential company strategy into a public chatbot to get a quick summary,
You've essentially read that secret strategy aloud to the entire university, and months later, that model might use the patterns it learned from your secret data to answer someone else's question.
that is terrifying.
It is. That's why private models exist.
This is the biggest decision companies are making right now. Okay, let's do a quick summary of the journey. We started with the undergraduate foundation. That's the sheer volume of reading to become a generalist.
Then campus connections, the neural net where hidden layers synthesize information.
Then we hit the math department, where different algorithms and orders of operation give models their unique personalities.
Then off to grad school for fine-tuning and specialization.
And finally, continuing education, where versions improve and we learn to keep our secrets out of the public lecture hall.
That's the University of AI.
It's such a powerful analogy, and Tricia's core philosophy here is so good. AI isn't magic. It's math and design amplified by scale.
Right. The tech is incredible, but it's not magic. And I think that leads to the big takeaway for me. We talked about how the model thinks differently than we do. We are emotional, intuitive, erratic sometimes.
We are.
Yeah.
And here's a thought to leave you with. Models don't have aha moments in the shower. They process patterns at scale. They don't know the truth. They just know the likelihood of the truth. And humans, we can't process 1 trillion tokens. We can't read the entire internet in a week.
We are effectively completely different species of thinkers.
We are. So the real breakthrough isn't the AI replacing the human, it's the partnership. It's where the AI handles the massive scale of pattern recognition, the grunt work of the universe, and the human steps in to provide the hypothesis, the meaning, the ethics, and the direction.
The student needs a mentor, and the mentor needs a researcher.
That collaboration is absolutely where the future is. And that leaves me with a final thought for you listening. Tricia points out that the most important variable isn't actually the model, it's the human. We are the ones choosing which school to send our data to and how to interpret the results.
We are the deans of the university.
But for now, stop looking at AI as a black box. Look at it as a student you're helping to teach.
I love that.
Hi, I'm Tricia. Thank you for watching, and I hope you enjoyed this presentation. Now I'm going to briefly share all of the tools that I used. I started by really talking through my brainstorming idea of the analogy with my GPT. I do this a lot. I brainstorm and I talk and I get ideas, and then I get the transcript to really get the summary of what we've talked about. I'd love to talk through and brainstorm with you, because a lot of people have been asking me about AI, what it is, what it does, and how it's useful. And so I'd like to give you my analogy of how I'm thinking about presenting my explanation of AI.
Absolutely, Tricia. I'm all ears. Analogies can be such a powerful way to demystify AI.
What I'm thinking is I'd like to explain it in a way that there are public universities and private universities.
That's a great way to show variety. So you could say large public universities are like general models.
Took the entire transcript of my interaction with ChatGPT and I put it into a Google Notebook LM. And from there, I created different media sources. I created an audio. I even created one of their videos to see how that turned out. It didn't exactly give me the output I wanted, which is why you'll see a custom version of my presentation. Just know that Google LM does have the capability of creating videos based on information and resources that you put into the Notebook LM you create. I then used my own editing tools. I used both Photoshop and Final Cut Pro. The whole process was then my own creativity of how I can utilize the tools and go back and forth between customizing the images that I received, audio that I got from Notebook LM. So I finalized everything through Final Cut Pro to put the entire presentation together. I think all of these tools are just getting better, and so I'm so excited to see how these tools enable us in the future, because technology is really a collaboration partnership to enable us to do amazing things and create output that to me is more professional, more custom, and more aligned with the type of work that I'd like to create. One thing I'd like to emphasize, and I hope no one thinks that this is just oh, AI can do this in just a few minutes. You just type some prompts and then boom, you get an output like this. This took days of research. It took days of thinking, hours of getting prompts and finding resources. It took hours of editing. So while AI is an amazing tool, I don't want to diminish the fact that it still takes a lot of work to use the tools and put things together in a way that really makes an output something that we can be proud to share.